Welcome back to another video. It's Dr. Tarcia Hubert here, and in this video we are going to be talking about applications of vectors. And so in the previous videos, if you've been watching them, we've been talking about vectors, everything about vectors and operations with the vectors. And in this video we're going to look at some word problems, some real life situations where you will use vectors. Before we get started, we have to address one new term called an equilibrant. And this is a vector that counterbalances the resultant vector. So remember, the resultant vector is found by adding two vectors. So taking the sum of two vectors. If you take the sum of two vectors, you get the resultant vector. Well, the equilibrant is the opposite of that resultant vector. So if you use u to represent the resultant vector, then negative u will be the equilibrant. Okay. And so we're going to be using that in the word problems that we look at today. We're going to go through three examples, real life examples of how you will use vectors. So let's jump right in. For this first example, we want to find the magnitude of the equilibrant of forces of 48 newtons and 60 newtons acting on a point A. If the angle between the forces is 50 degrees, then we want to find the angle between the equilibrant and the 48 newton force. Alrighty. So first thing we have to do is we have to sketch a picture. That's always what you want to start off doing. Sketching a picture. And so let's start off by sketching a picture. So we have two vectors. The first vector, I'm just going to draw a line. This represents our 48 newton vector. And there's another vector that's 60 newtons. So remember, that represents the magnitude. So this will be 60, and they're acting on a point here, A. Alrighty. And the angle between them is 50 degrees. Alrighty. So we want to find the magnitude of the equilibrium. So the first thing we will have to do is find the resultant vector. So remember, we will find the resultant vector by creating a parallelogram. So I'm going to do my best to sketch out this parallelogram. And so the resultant vector would go from this point. So the resultant vector would go from that point A to the corner here. And so then equilibrium will be the opposite of that. So remember, it's the same length, but in a different direction. So imagine that's the same length as that vector, but just going in a different direction. So the first one that I drew on the inside will be the resultant vector, and the second one will be the equilibrium. Okay. So let's just label this. We're going to label this side over here B. We'll label this side C. And remember, in a parallelogram, adjacent angles are supplementary. So that means this 50-degree angle here and this angle here are supplementary. I mean, they add to 180. So that means this angle here has to be 130 degrees. So now we have this triangle. And this is our resultant vector here. I'm going to call that little b because it's opposite what I call B. And then this side over here is parallel to the 60 side, the force of 60. So that's also 60. So we have this triangle up here at the top. Let me change my, oh, no, that's not what I want to do. Let me change, I can't see. This is what I wanted to do. So I wanted to get this pointer. So now you see we have this triangle here at the top. It has, we don't know what this angle is, but we know this angle is 130. We know this side is 48. We know this side is 60. So we know a side, an angle, and a side. Alrighty. So when we know a side, angle, and a side, we can use the, if y'all remember, law of cosines. And so for the law of cosines, we can find the other side, which is little b. So remember, b squared is equal to the other side squared plus the other side squared. So the two sides that we know, we square those. And then we subtract 2 times those sides. So 48 and 60 times the cosine of the angle between them. So times the cosine of 130 degrees. And so if you plug all of that into your calculator, 48 squared plus 60 squared minus 2 times 48 times 60 times the cosine of 130 you get that to be 9,606.456632. And then if you take the square root of that, so you get b squared equal 9606.456632. Again, you don't have to write this part out, but I'm just giving you a reference. If you take the square root of that answer, you get 98.1. So B ends up equaling, and if we round it to the nearest two significant digits, it'll be 98. So our resultant vector, the magnitude of it is 98. And the equilibrium and the resultant vector have the same magnitude. So the magnitude of the equilibrium would also be 98, because remember, they're exactly the same. They're just going in opposite directions. Now we need to find the angle between the equilibrium and then the 48 Newton force. So that would be this angle here. Let me get my pointer. I keep pushing the wrong thing. I get my pointer. No. All right. So the angle between the 48 Newton, so here's the 48 Newton, and the equilibrium, that's this one right here. So we want to know, what is this angle right here? This angle. So I'm going to draw, and let me draw it in a different color. Get my pen, and no, keep pushing the wrong one. And I'm going to do red. All right. So that's this angle right here. That's the angle we're looking for. I'm going to call that alpha. That's an alpha symbol right there. Well, alpha is going to be 180 minus this angle right here. So we can figure out this angle, and then we do 180 minus that to figure out what alpha is. So in order to subtract or to figure out this angle, we can now use the law of sines, because we know this side, we're looking for this angle, and we know this angle, and we know this side. So since we're looking for an angle, I'm going to call that angle ABC, because it's not angle A. Angle A is the whole thing. So I'm going to say the sine of ABC over 60 is equal to the sine of 130. And since we're looking for the angle, remember you put the angle on top. The sine of 130 degrees over 98. And so if you want to solve for the sine of ABC, we multiply both sides by 60, and we get the sine of ABC equal to, so if you do sine of 130, plug it in your calculator, divided by 98 times 60, you get that to be 4.4690068019. Hopefully you're working this with me, and hopefully you got that. And so in order to solve for the angle here, so remember that's the angle ABC, you would do the inverse sine of that. So angle ABC will be equal to the inverse sine of that value, which is 27.9698, and everything is given to two significant digits. So if I round that to two significant digits, that'll be 28 degrees. So that means this portion of the angle is 28. So to find alpha, we would do 180 minus 28, which is equal to 152 degrees. Alrighty. So our alpha, which is this angle right here, that's the angle between the 48 Newton equilibrium, the 48 Newton force and the equilibrium. That will be 152 degrees. Alrighty. So we found the magnitude and we found the angle between those two forces, and we are done with the problem. So if you have any questions about anything we did in this problem, feel free to put them in the comments below and I will respond. If not, let's go look at another example. For example 2, we have a force of 16 pounds is required to hold a 40-pound lawnmower on an incline. What angle does, that's supposed to say does, the incline make with the horizontal? All right, so we have an incline. I'm going to sketch it out. We have an incline. We have a lawnmower that's on the incline. And so that's my lawnmower. Imagine that's a lawnmower. And so we have that we know that lawnmower is 40 pounds. Oh yeah, 40 pounds. And so the weight of the lawnmower is going to pull down. So first of all, let me finish my incline. So my incline, first of all, creates a right triangle with the ground. All right. The force or the weight of the lawnmower pulls directly down. And so that would be, the magnitude of that would be 40 because it pulls directly down. Now it says there's a force of 16 pounds that's required to hold it up. So the force is pulling at a parallel with the incline. So the force is pulling this way, and it's 16. So that's a 16 right there. It's 16 pounds. And so we can have a line parallel to that here that's also 16. And so what we end up having is a right triangle here. So that's a right triangle that is formed by doing the force of the lawnmower and the force that's pulling the lawnmower to hold it up to make it stay still. And we want to know what is the angle that the incline makes with the horizontal. So here's the actual angle that we want. We'll call that theta. That's the angle right there we're looking for, okay? So we can use the fact that we know that this is a right triangle. We know that this side is 40 and this other side is 16. And we can find this angle here. I'm going to call this angle alpha. And we can say, because that is the opposite and the hypotenuse, so we will say the sine of alpha is equal to 16 over 40. And so in order to solve for alpha, we would take the inverse sine of 16 over 40. This is 16 over 40. That's it, 16 over 40, guys. So the inverse sine of 16 over 40 is equal to 23.57. Everything is given to 3 significant digits. So we'll say alpha is 23.6 degrees approximately. Okay. Well, since this is alpha, so let me get my pointer so y'all can see. Pointer. Okay. This is alpha right here, right? Now, this right here also makes a 90-degree angle. So this triangle that has the angle that we're looking for it in makes a 90-degree angle. This triangle here also makes a 90-degree angle. So if this angle is 23.6 degrees, then this angle would be 90 minus 23.6, which is 66.4 degrees. So 66.4 degrees would be this angle right here. That angle there is 66.4 degrees. Now I'm saying that because we have a right triangle here. This is also a right triangle. It says this is a right triangle here. That means this angle here would be 90 minus 66.4, which is the 23.6 degrees. So the angle that we're looking for, theta, would be equal to 23.6 degrees. Let me rewrite that. So theta will be equal to 23.6. Does that make sense? Why? Hopefully it makes sense why. So again, we have a 90-degree angle here. We have a 90-degree angle here. I know it's a lot going on in this triangle. Because this one, this alpha is 23.6. The other one would be 70 or 66.4, which would mean this one here would have to be 23.6. Okay? So that's how we work that problem. Okay, for this last example, example 3, we have a ship leaves port on a bearing of 28 degrees and travels 8.20 miles. The ship then turns due east and travels 4.30 miles. How far is the ship from port and what is its bearing from port? Okay, so the first thing we want to do is we want to sketch a picture. So let's say the port is here. So we have a point P here. Remember, bearing, if it doesn't give a direction, then it starts from due north. And it's 28 degrees, so it goes in a clockwise direction. So 28 degrees would be something like that. So this is the 28-degree angle. And so it travels for 8.2 miles. So this would be the 8.2, the magnitude of that vector. Then it turns due east. So due east means from this point, it starts to go directly east, and it travels for 4.3 miles. Alrighty. How far is the ship from port? So we want to know, what is the distance from this point P to this point right here? So if you notice, we have a triangle. We have a triangle that gives us, we have the angle here. We also have this angle here. And so we can actually figure out what this angle is here by determining what this angle is. So this creates a right triangle right here. Let's see. So this is a right triangle. Since this one is 28 degrees, this angle here is going to be 90 minus 28, which would be 62 degrees. So this angle here would be 62. So that's this angle here. That's 62 degrees. And so just so y'all can see, this is 62 degrees, this angle right here. And so this angle will be supplementary to this angle right here. So it'll be 180 minus 62, which is 118 degrees. So now we have a side angle and a side. And remember, whenever you have a side angle and a side, you can use the law of cosines. So I want to find, so if I label that's P, let's call this point A and this point B, then I want to find little a. So to find little a, I would say little a squared is equal to B squared, which is the 8.2 squared, plus the P squared, which is 4.3 squared, minus 2 times the little b times the little p, 4.3 times the cosine of the 118 degrees. If you plug all that in your calculator, you get 8.2 squared plus 4.3 squared minus 2 times 8.2 times 4.3 times cosine of 118. You get 118.8371346. So a squared is equal to, again, you don't have to write this out. I'm just giving you a point of reference so you can see if you're getting the same answers as me. And then you would take the square root of that answer to solve for a. And you would get a is approximately, and everything is to 3 significant digits. So we'll say 10.9. So this distance here is 10.9. That means the boat, the ship, is 10.9 miles from the port. So that's the first part. It says how far is the ship from the port. That's the first part. Now there's a second part that says what is its bearing from port. So its bearing would actually be this whole angle right here. But we need to figure out this angle right here. So now we can use the law of sines because we know the angle opposite that angle, and then we know the 118 degree angle and the length of the side opposite of that. So we'll call this angle, let's call that angle, we'll say that's alpha. That's this inside angle right here. So we want to say sine of alpha over 4.3 because 4.3 is the length of the side that's opposite that angle, is equal to sine of 118 degrees all over 10.9. So we get sine of alpha is equal to 4.3 times the sine of 118 all over 10.9. If you plug that in your calculator, 4.3 times the sine of 118 divided by 10.9, you get sine of alpha is equal to 0.34831. That's equal to 0.34831,877, and some more numbers, 52. I'll put them here. But in order to solve for alpha, you will take the inverse sine of that. And when you take the inverse sine of that, you get 20.38. So you get alpha is equal to, if you round it to 3 significant digits, it will be 20.4 degrees. Now that's alpha, which is this over here. Let me get my pointer so y'all can see. So alpha is this angle right here. And remember, we want to know this whole angle. This will give us the bearing. So in order to figure out that whole angle, we have to take this 20.4 degrees and add it to this 28. So the bearing would actually be 28 plus 20.4, which will be 48.4 degrees. So that would be the bearing of the ship. It will be 48.4 degrees, and then it'll be 10.9 miles away. So that's how you would solve that problem. If you have any questions whatsoever about what we did, you have to always sketch a picture first and then look at what you know. And depending on what you know, that will determine what do you use to actually solve it. So if you have any questions at all about this problem, don't hesitate to put them in the comments below. If you understood everything in this video, if it helped you to understand, go ahead and hit the thumbs up. If not, I will see you all in the next video.